Somewhere in a lab, a single particle meets its opposite, and for a fraction of a second, matter simply ceases to exist. A single gram of antimatter contains enough energy to level a city block if it ever met its opposite. That's not science fiction math, that's basic physics, straight from Einstein's equation. Most people picture antimatter as something exotic, locked away in a distant future. It isn't. Antimatter exists right now, all around you, just in vanishingly small amounts. Dr. Michael Dozer, a physicist at CERN who has spent decades studying antimatter, works with some of the only facilities on Earth capable of creating and trapping it. His research focuses on something most people never expect. Antimatter isn't dangerous because of what it does. It's dangerous because of what happens when it touches ordinary matter. When a particle meets its antiparticle, both are annihilated completely, converting 100% of their combined mass directly into energy. Compare that to a nuclear bomb, which converts less than 1% of its fuel's mass into energy. Which means gram for gram, antimatter annihilation is over 100 times more powerful than nuclear fission. So why hasn't anyone built an antimatter weapon? Because making antimatter is absurdly, almost comically inefficient. CERN's facilities can produce only about 10 million antiprotons per minute under ideal conditions. At that rate, producing just 1 gram of antimatter would take longer than the current age of the universe, which means the danger was never really about antimatter being made in dangerous quantities. It's about how far science still is from making it in any meaningful amount at all. Here's the part almost nobody expects. The largest quantities of antimatter ever created and stored on Earth amount to a few trillionths of a gram. At CERN, physicists have managed to trap anti-hydrogen atoms for over 16 minutes using powerful magnetic fields, which means the current record for storing antimatter is measured in atoms, not grams, and in minutes, not indefinitely. So what would actually happen if antimatter met matter on a larger scale? The reaction would release energy as gamma rays, the most energetic form of light, radiating outward in all directions. Unlike a nuclear explosion, there would be no leftover radioactive fallout. The annihilation converts mass completely, leaving nothing behind but pure energy. Which means an antimatter reaction is, strangely, the cleanest possible explosion physics allows, and also one of the most immediately lethal. Here's where the story gets stranger. Antimatter exists naturally, in tiny amounts, produced by cosmic rays, lightning, and even inside your own body from radioactive potassium decay. Researchers estimate a banana contains enough naturally occurring antimatter to produce roughly 1 positron-electron annihilation event per hour, which means you have been standing near antimatter annihilation your entire life at a scale too small to ever notice. So if a person was somehow near a large antimatter release, what would survival actually depend on? Distance, primarily, since gamma radiation intensity drops sharply the farther you are from the source. Physical shielding, like thick concrete or lead, can absorb a significant portion of gamma radiation exposure, which means the same principles that protect against other forms of radiation exposure would apply here, just against a far more concentrated and immediate release. Here's the part physicists find genuinely fascinating. Antimatter research today focuses almost entirely on studying fundamental physics, not weapons development. Scientists want to know why the universe is made almost entirely of matter when the Big Bang should have created equal amounts of both. Which means antimatter remains one of physics' biggest open mysteries, tied to a question about why anything exists at all. So, could you actually survive being near an antimatter explosion? For any explosion of meaningful size, survival would depend entirely on distance and shielding, the same as any high-energy radiation event. But the honest answer is stranger than the danger itself. The amount of antimatter humanity can currently produce is so small that this scenario remains almost entirely theoretical. Antimatter has existed since the earliest moments of the universe, in an imbalance physicists still cannot fully explain. And maybe that's the real reframe. We imagine antimatter as humanity's most dangerous invention, waiting to be weaponized. But it may be one of the few forces in nature we're nowhere close to controlling, let alone containing. The real question was never whether you could survive an antimatter explosion. It's why the universe let matter survive at all.